Hello all. In this video, we will study fork system call. So imagine, suppose we have some process, say A, and its PID is say 23. PID means process identification number. And suppose that process executes a fork system call. Then what will happen is it will create a child process. Imagine say that child process is named as B, and if its PID is say 41. Process identification number for child is 41. Now this fork system call does not take any arguments, but upon successful completion, fork system call returns two values. One value is returned to parent and another value is returned to child. So what basically fork returns? Fork creates child, and then this child will always get a value 0 from fork, right? A return value as 0 from fork. Whereas parent will always get child PID. Parent will always get child PID. In case if fork system call fails, then it will return -1. So let's see an example. So consider this program, a C program illustrating the use of fork system call. So when this program executes, it becomes a process. So imagine if it is process A, and moreover also imagine that its PID is say 23. Right? PID is some number which is greater than 0. So its PID is say 23. Now there is a variable X declared within this program. So process A will have its own copy of X. Process A will have its own copy of X. Then this process A calls fork. So when it calls fork, and if fork successfully completes its execution, then a child is created, say B. Okay. Now child will have some PID which is certainly different from parent's PID, because PID is unique for every process. So child's PID is say 41. Now since child is an exact replica of parent, child inherits everything from parent, and when it inherits everything from parent, it will also inherit X. It will also inherit X. So there will be a separate copy of X for child as well, and then there is a separate copy of X for parent as well. Now both of the processes will execute independently, but now when they execute, fork has actually returned some value into X. Right? Now I have already told you that parent always gets child PID. Now what is the child PID? Child PID is 41. So parent will get 41, which will be copied into this variable X, right? Into this variable X. Whereas child always gets 0 from fork, as what I already told you, right? Child gets 0 from fork, so child's X means B's X will be 0, and parent gets child's PID. Imagine that child's PID is 41, so parent's X, that is process A's X, would be 41, and then this code will be executed by A as well as by B. When A executes this code, for A this condition is false, right? For A this condition is false, X is not 0. So for parent this condition is true, so it prints a message, I am parent. Okay, so parent prints a message, I am parent. Whereas when child runs, for child this if condition is true, if X is equal to 0 is true, and since this condition is true, child will print a message, I am child. So the output of this program will be, I am parent, I am child, provided parent gets chance to execute printf first. If parent gets chance to execute printf first, then the order of output would be I am parent, I am child. But in case if child gets chance to execute printf first, then the output will be I am child and then I am parent. Okay, so it all depends upon how the processes gets scheduled. So you don't know in what order the output will be printed, but one thing for sure, that parent will print I am parent and child will print I am child. The order in which they will run cannot be predicted. Now in case if fork fails, then in that case child is not created, and if child is not created, then fork will return -1. So then for parent this condition will be true, for a this condition will be true, because fork returns -1, and then you will print fork failed. Okay, so I hope you have understood this. Thank you.